Hello everyone, welcome back to my YouTube channel, and today is the lecture number 6 of the lecture series Electric Vehicle Full Course, and today we are going to learn the mastering in BMS. In first lecture of BMS we have gone through with the fundamental works and function of BMS and what is the role inside the battery pack and overall electric vehicle. But today we are going to decode the individual functions and how the science is working behind that. So without wasting any time, let's start it. And today's agenda is very much clear. First of all, today we are going to understand. See, let me summarize just for in 1 minute. We understand that BMS is protecting from overcharging and discharging. But let us understand today how. Second thing, we discussed in previous class that BMS is overcoming the temperature issues. And today, how BMS is overcoming the temperature issues, and similarly how BMS is performing the cell balancing. Today we will understand how cell balancing is performed by the BMS. And the fourth one is what? How BMS is monitoring SOC and SOH, state of charge and state of health. And today we are going to decode that, how it is doing. And the fifth one is BMS is helping in communication. So today we will understand how BMS is passing the information from battery pack to the master controller or to the driver, and how BMS is providing overall safety. We know we are using BMS just for the safety and efficiency, but overall today we will understand how BMS is providing the overall efficiency. So let's start from the first slide. So friends, if you are new here, please subscribe and share the videos to your friends, and that will boost my energy at least. So here you can see this one, this board is what this PCB is, nothing else, it is a BMS PCB. Okay, and many types of BMS is coming in the market, but let us go ahead with how BMS is protecting from overcharging and over discharging. Okay, so this is the question. How we are going to respond it? Let us understand. Let us learn it first. See, overcharging a protection. That means what? How it will protect? What is the possibility behind that? Suppose we have this battery pack, okay, and it is now 100% charged. So how? Because so that means what? With the help of some sensors, okay, with the help of some sensing capabilities of the battery pack, and which is coming because of the battery management system. So that give the input to the BMS, and so that BMS can cut off the power to supply the additional charge. Okay, so how it is what? In overcharging protection, first part is what? The voltage monitoring. So BMS continuously monitors the voltage of each individual cells in the battery pack. That means what? Because see, we are using the same cells, but there is a differences in very small differences in their voltage. We cannot use 3.6 volt cells. There is a difference, very nominal differences, and that create a big difference in a battery pack. So if any cell voltage approaches its maximum safe limit, the BMS takes action. What kind of action that will take? It will detach. Okay, detach from the charging system, or you can see the disconnect it from charging system. And second one was what? Charging control. So everything is done because of the charging control only. When the voltage gets too high, the BMS can signal the charger to reduce the charging current. Okay, and this is what the charging and discharging, especially this is the battery overcharge protection circuit. And if you are from electrical background, you can read it properly, but in today's agenda I am not keeping this part, how this circuit is working. And if I'll get a good response of this video, from this video, definitely I will go into the deep for you and will make another video for that. and this prevents cell from the exceeding their safe voltage. Suppose एक हमारे पास एक cell है and this one is what, suppose this one is one single cell and हम इसे देख रहे हैं, this is continuously charging and it is reaching up to the maximum limit. So that means there is some sensor, sort of sensor, that giving the input to our BMS that this particular cell number, suppose this is cell number 1, is charged. So what BMS will do? BMS will disconnect it. Okay, suppose this one is one cell, so BMS disconnected from getting charged. So in this way it is protecting from the overcharging conditions. Okay, let's move ahead. And over discharging protection, see, because we are using this one cell, this is a 2 cell. Okay, just take example with this small one. So in overcharging protection, it is also the monitoring of voltage. It is very much important. Suppose the rated voltage is 3.6 volt, so that should not go beyond that. Okay, so that voltage should remains constant throughout the operation. And here what we can see is, suppose this one is just one cell, this one is a other cell, and continuously it is into the operation. The charges go outside. So what will happen? This will decrease, and suppose it is reached up to the here, up to the 1% or 2%, and slightly with the certain kind of tolerance, suppose it is reaching up to the 0.5% of charging. Alright, less than to just more than 0. So what the BMS will do? BMS will just disconnect this particular circuit so that the additional charges should not go outside now for the safety purpose of this cell. So this is how the BMS can cut off the load. Load means who is taking the charge. Okay, so individual cell is supplying with the help of battery pack. So what the BMS will do is, smart BMS are just cutting off this particular cell from the operation so that it can be saved. And the device using the battery, or reduce the discharge current when detects a cell is nearing its minimum safe voltage. Okay, so that is very much important. We understand, because there is a lot of huge number of sensors we are using inside the BMS, inside the battery pack, for many reasons, and current and voltage is one of them. And this helps to prevent damage of the battery, extend its overall lifespan. And if the battery will not discharge completely or will not over discharging basically, so the lifespan of battery automatically will increase. So that is what the BMS is doing here. And how BMS is overcoming the temperature issue, that is the question number 2. Stay here friends, we will learn one by one. These are the questions asked by the industry people in the interviews. So one by one you will understand the exact things behind the questions. And if you are looking for a study material of this complete electric vehicle training course, so you can just simply message here on this given number. And if you are looking for the certification, you can just contact, you can just message on WhatsApp, you will get the details from there. And the BMS, how BMS is overcoming the temperature issues. First one is the temperature monitoring. So BMS is doing the monitoring of temperature with the help of, suppose this one is one battery pack, and inside here there is a lot of cells are there. So BMS is using the temperature sensor. What it is? Temperature sensor. And from there it is continuously getting the feedbacks. What is the current status of temperature inside the battery pack? So as we know, the optimum or working temperature of EV is around, I'm considering 25 degrees centigrade to 35 degrees centigrade. So if it is below this temperature, going below, so BMS will give the information to sensors will give the information to the BMS, and BMS will take the appropriate action. If temperature is going below the 15 degrees centigrade, so that means heating system of the EV electric vehicle should start? Huh? Suppose if it is 10 degrees centigrade sometime, or that is okay, okay for some time. But if it is for long time, 10 degrees centigrade or below 10 degrees, suppose it is near to 0 degrees centigrade, we are operating in something Leh and Ladakh and very cold region of this planet. So what will happen? So we need a certain heating system. So there is a two system exist in electric vehicle. The cooling system talked by many persons. Everyone is talking about the cooling system of electric vehicle, but the heating system is also exist to make it a proper temperature, because temperature can decrease and increase also, but may often the temperature is increasing. So that's why cooling system is very much popular. But in case of we are operating at a very below temperature, surrounding temperature is very less, so in that case heating system is going to play very important role. Okay, so that is what continuously monitor the temperature of individual cells and overall pack. Simply, if suppose the temperature of one cell is going beyond the 35-40 degrees centigrade or near to 50 degrees centigrade, so BMS will disconnect that cell from the operation. Got it or not? Okay. And real time data, because this is the sensor closed loop feedback kind of system inside the BMS. So that's why the real time data allows the BMS to detect any abnormal temperature variation in hotspot. So consider that complete battery is what a hotspot kind of. So we are getting the BMS is getting the real time data from their sensors and support systems. Okay friends, let's move ahead. So thermal management strategies. What are the basic strategies? How this is doing that? So cooling system. So if temperature is going beyond 35 degrees centigrade, so the cooling system is providing the additional cooling effect. Okay, additional cooling effect. So BMS detect that the temperature is rising too high, and it can activate cooling systems such as fans, liquid cooling, or even advanced method like a phase change materials we are using. If the temperature is increasing, so automatically that converts into the liquid form and giving the cooling to for the better dissipation of heat. So that is very much important. And heating system, when we are operating this heating system in cold conditions, the BMS can activate heating systems to bring the battery up its optimal operator. As I told you initially, we have two systems, cooling system and heating system, and both is working. Depends upon, suppose I am a rider from India and living in a Rajasthan at a very warm place. So what will happen if I want to travel with my electric vehicle to the Leh and Ladakh or Kashmir in north part of the India? What will happen? Suddenly I am going to operate my vehicle from 45 degrees centigrade to directly 10 degrees centigrade or up to the -10 or -20 degrees centigrade. So that heating system will allow me to do that. Otherwise electric vehicle will not survive there. I hope you understand. And how this cooling system is working, let me give you the brief idea about how it is going, how BMS is taking. Suppose this one is a battery pack, okay, and this one is what, your battery pack. And suppose BMS detects, just 1 minute, okay, I will not take much time. And suppose BMS detect the temperature is what here, temperature is around reaching going beyond the 50 degrees centigrade. Obviously that is a dangerous temperature for electric vehicle. Even up to 60-65 this is going to collapse. 70 degree it is unbearable for the many electric vehicle components. So this 50 degrees, suppose going to 50 degree centigrade, and we have here a cooling system. This is what CS, there is a cooling system is here. So it is already activated actually to maintain the overall temperature. But suppose the cell number 5, this cell number, both the cell are getting high heat because of many reasons maybe. So what will happen, that cooling system will take care, BMS will supply the additional cooling environment to these cells which are in series or parallel. That will recognize that layer of battery pack and provide the additional cooling for making it better, for making it safer. I hope now you understand. what is exactly, because the cooling system in electric vehicle, it is designed for each and every cell for efficient. In previous class I discussed just little about the Tesla cooling tubes. So that is what providing the single cells cooling, providing cooling to single cells. And similarly it is working for the heating system also. Let's move ahead. And load management, how it is doing the see, in temperature we have gone through with the both two, and third one is what? Load management. The current control, BMS can reduce the charging or discharging current to lower the heat generated within the cells, and thus preventing the overheating. What BMS is doing? Suppose BMS can control the, what it is doing, it can control the I think this is not control the rate of charging एंड डिस्चार्ज. ये देखिए बहुत महत्वपूर्ण है कि जो हमारा व्हीकल चार्ज हो रही है ना, तो रेट ऑफ चार्जिंग और डिस्चार्जिंग को अगर हम कंट्रोल कर पाएंगे, सो हीट को हम उस तरीके से मैनेज कर पाएंगे. अगर रेट ऑफ चार्जिंग को नहीं कंट्रोल कर पाएंगे तो जिस रेट से करंट आ रहा है, टेम्परेचर अगर बढ़ेगा तो उसी रेट से करंट आएगा. और सिमिलरली अगर टेम्परेचर डाउन जा रहा है तो जिस रेट से करंट पुल हो रहा है, लोड पे जा रहा है, और सी इन ऑपरेशन कंडीशन टेम्परेचर जो है डाउन नहीं होता है नॉर्मली. इट डिपेंड्स अपॉन द हीटिंग सिस्टम, इज डिजाइन फॉर द सराउंडिंग टेम्परेचर टू बैलेंस द सराउंडिंग टेम्परेचर. बट जस्ट फॉर एन एग्जाम्पल कि दैट the rate of controlling the rate of charging or discharging is very much important for making the safer battery pack. And there is a shutdown protocols. In extreme conditions causes the BMS can shut down the battery pack or a specific section of it to prevent the thermal runaway and ensure safety. See, in case of excessive heating, battery pack can blast and caught fire. So to avoid that situation, suppose temperature is reaching up to the 75 degrees centigrade. That is the extreme condition for it. So what BMS will do? BMS will cut off. Otherwise, thermal runaway will be there. There may be the explosion or any other thing. Means serious accident could be there. And how it is balancing cell temperature? Number fourth one is what? Balancing the cell temperature. So uniform heating and cooling is very much important. Every cell is getting the uniform temperature in charging and in discharging both case. To manage the suppose cell number 1 has 20 degrees centigrade and cell number 100 is something 45 degrees centigrade, so that create problem actually to manage all these cells. Okay, fine. So what will happen if we are doing this particularly things, suppose how it is predicting the maintenance. Data analysis by the analyzing historical temperature data, the BMS can predict potential issues and recommend maintenance before they become critical. See, because आप जब vehicle operate करते होंगे, you can see the dashboard in front of you, digital dashboard, and here you can see the many like indicators are there. Some is for high temperature, some is for service, some is for the kind of cooling problems. Indicators are there, so that BMS is ensuring with the help of data analysis, BMS is ensuring that this is the time of service, and you should send your vehicle for the service purpose. So in order to this, otherwise क्या होगा कि हम टाइम पे सर्विस नहीं लेके जाएंगे कि कितने किलोमीटर पे हमारी सर्विसिंग होनी है. एक इंडिकेटर रहता है कि आप टाइम से सर्विस कराते हैं व्हीकल्स की, तो उसकी लाइफ स्पैन जो है व्हीकल का, दैट इंक्रीज. एंड नाउ लेट अस कम ऑन द क्वेश्चन नंबर 3. आई होप आपको ये 2 नंबर तक पूरी तरह से क्लियर होगा. वी हैव टोटल 6 क्वेश्चंस. हाफ ऑफ टाइम हम लोग लगभग कवर कर चुके हैं, थोड़ा सा और. लेट अस. एंड हाउ BMS इज परफॉर्मिंग सेल बैलेंसिंग. दिस वन इज इंपॉर्टेंट. सेल बैलेंसिंग आपने बहुत जगह पे पढ़ा होगा, छोटे छोटे शॉर्ट्स भी आते हैं, छोटे छोटे वीडियो जो लोगों ने बना दिया है. तो अब अभी हम लोग देखते हैं कि भाई सेल इम्बैलेंस होती क्यों है. पहला क्वेश्चन है, बैलेंसिंग तो देख लेते हैं. Cell balancing is a crucial function that battery management system ensure all cells of battery pack maintain the same voltage level or same current level, and that is important for individual cells can have slightly variations in capacity. This is possible. मैंने बताया कि सबका कैपेसिटी एकदम सेम नहीं होता, बहुत थोड़ा थोड़ा नॉमिनल डिफरेंसेस होते हैं जो एक बैटरी पैक में आने के बाद बहुत बड़े बन जाते हैं, है ना. इम्बैलेंस ओवर हियर इज द हाउ सेल इम्बैलेंसिंग इज वर्किंग. सो व्हाई सेल्स बिकम इम्बैलेंस, दे ये क्वेश्चन इंटरव्यू में पूछे जाते हैं. जस्ट टेल मी व्हाई देयर इज ए इम्बैलेंसिंग विद इन द सेल्स. सो डू यू हैव एनी आंसर? Let us understand. Otherwise, if you know the better answer of this, you can go into the comment box and write there. Cell imbalancing during the charging, just make it thoda patla. Charging discharging can result from various factors including different cell capacity. This is the first region. What is it? Cell capacity. Okay, cell capacity. And second one is what? Internal resistance. Very nice. यहाँ पे लिख लो internal resistance. And third one is what? Temperature. Third one is what? Temperature. And fourth one is what? Aging, means time. Old है या new है उस पर डिपेंड करेगा. तो ये 4 फैक्टर्स हैं जो आपके क्या कहते हैं सेल इम्बैलेंस के लिए रिस्पॉन्सिबल है. सो व्हाट विल हैपन इफ देयर इज अ वेरिएशन इन सेल कैपेसिटी, इंटरनल रेजिस्टेंस, टेम्परेचर, एजिंग, दे विल cause the cell imbalancing in battery pack. Let us understand one by one. What will happen in variation? पहले हम imbalance का रीजन जान लेते हैं, फिर उसको बैलेंस करना सीख लेते हैं. दोनों जो मेथड है हमारे पॉपुलर है. Even in a battery pack with the cell of the same model, each cell may have slight differences. ये बहुत इंपॉर्टेंट है. एक ही मॉडल का हम ले आएंगे बट थोड़ा थोड़ा डिफरेंस हो सकता है इन कैपेसिटी. हो सकता है आगे जब टेक्नोलॉजी हमारी और अच्छी होगी, बहुत इंप्रूव होगा, दैट रीजन में भी नेगोशिएटेड. ड्यूरिंग द चार्जिंग और डिस्चार्जिंग, सेल्स विद अ लोअर कैपेसिटी रीच फुल चार्ज और डिस्चार्ज बिफोर अदर्स, क्रिएटिंग एन इम्बैलेंस. आई होप दिस पॉइंट इज क्लियर. पहला चीज है कि ऐसा हो सकता है कि जो थोड़ा कैपेसिटी में डिफरेंस होता है, सो सेल्स जिसकी कैपेसिटी कम होगी वो जल्दी डिस्चार्ज हो सकती है, जल्दी चार्ज हो सकती है, एंड दैट इज द रीजन ऑफ इम्बैलेंसिंग. अदर ज़्यादा टाइम लेंगी. एंड डिफरेंसेस इन इंटरनल रेजिस्टेंस, ईच सेल हैज ए यूनिक इंटरनल रेजिस्टेंस विच कैन चेंज ओवर टाइम. एंड मेनी फैक्टर्स हैं इंटरनल रेजिस्टेंस चेंज होने का, जैसे टेम्परेचर हो गया, वोल्टेज हो गया, तो ये वेरी करता है. तो इंटरनल रेजिस्टेंस भी क्या होता है, चेंज हो जाता है. इवन मटेरियल्स पे भी चेंज हो जाता है. हायर इंटरनल रेजिस्टेंस कॉज सम सेल्स टू हीट अप मोर और लेस, लॉस एनर्जी फास्टर देन अदर्स, लीडिंग टू द uneven charging and discharging time. So that is again a reason for imbalancing. And the next one is what? The temperature effect. As I told you, temperature fluctuations affect the rate of chemical reactions in cell. So rate of reaction agar tej hoga, so what will happen if rate of reaction is increasing? So charging discharging time may be different. And cells warmers areas of the pack may be charged or discharged faster. टेम्परेचर बढ़ेगा, मॉलिक्यूलर एजिटेशन बढ़ेगा, तो चार्जिंग डिस्चार्जिंग में भी डिफरेंट, अब फास्टर हो जाएगा. एंड क्रिएटिंग वोल्टेज एंड स्टेट ऑफ चार्ज डिफरेंस अक्रॉस द पैक. सो दैट इज व्हाट? क्रिएटिंग द इम्बैलेंस. एंड व्हाट इज द सेल एजिंग? सेल डिग्रेड एट डिफरेंट रेट्स ड्यू टू माइनर डिफरेंसेस इन मैन्युफैक्चरिंग एंड यूजेज. Older cells may have the reduced capacity and higher internal resistance and leading to the earlier voltage drop and unbalancing. See, if it is you are comparing new cells to old ones, so that means what? The old cell, the performance of old cell will be very less. And the reason behind is what? Reduced capacity and higher internal resistance with respect to time. And inconsistent, next one is what? Inconsistent charging and discharging. And trust me, suppose today you charge your vehicle 60% just for your operation, then you 80%, then 90%, 100%, then 30%. So we are not charging it fully or half charge. So that is also our commitment with our vehicle is also very much important for making it not to be imbalanced, cell imbalancing. So we are also the one reason. Repeated cycles of incomplete charging or discharging can create memory effects in some cells, causing them to hold less charge and contribute imbalance over time. So make sure when you are charging, keep it at least more than 80% or 100%, charge it. And because if you are connecting your vehicle for one time charging, so that one cycle is completed. And in one cycle, if every cell is not getting a full charge, so that means what, we are playing with the लाइफ स्पैन ऑफ द बैटरी पैक. ओके, सो आई थिंक अब तक आपका क्लियर हो गया होगा. अब जब रीजन समझ गए, लेट अस मूव फॉर द बैलेंसिंग भी देख लेते हैं कि बैलेंसिंग हो कैसे रही है यहाँ पे. ओके, सो फर्स्ट वन इज वन, वी हैव टू टाइप्स ऑफ बैलेंसिंग, दैट इज एक्टिव एंड सेकेंड वन इज व्हाट, वी हैव पैसिव. तो पहले हम लोग पैसिव समझ लेते हैं, ये इजी है, थोड़ा यूजर फ्रेंडली भी ज़्यादा है. लेट अस सी resistive method. This is called the resistive method. Passive one है, excess energy from the higher cell voltage cell is dissipated. See, हम लोग क्या किए, ये देखिए, ये हमारा बैटरी पैक है, 1 2 3, ये क्या है, बैटरी पैक है, ये सेल्स हैं, 1 2 3 सेल यहाँ पे हैं सीरीज पैरेलल में, ऐसे 5 and 3, then 5 and 3 you can see here. So what we are doing, suppose the cell, this cell has, this cell has, and this cell has different charges, and suppose this one is what, charge up to the this level, this one is charge up to the this level, and this one is charge up to the this level. So what will happen at this level, so these cells, cell number 1, cell number 2, and this is what, cell number 3, and you can consider this one is charge up to this point, this one is charge up to this point, and this one is charge up to this point. So the balancing will be done. What will happen, the additional, we are connecting this, see, we have connected the resistors here. We have connected the resistor just for purpose to release the current in the terms of heat. So हम लोग एडिशनल करंट को क्या करेंगे, यहाँ पे हमने एक रजिस्टर ये कनेक्ट कर दिया, अब यहाँ से करंट निकलेगा और ये हीट के फॉर्म में यहाँ पे बाहर निकल जाएगा, और इसके साथ भी कनेक्टेड रहता है, बट इसको बाहर निकलने की जरूरत नहीं है क्योंकि इसका चार्ज ऑलरेडी लेस है. तो थोड़े समय के बाद व्हाट वी विल सी, यहाँ से भी थोड़े चार्ज जो हैं हीट के टर्म में यहाँ पे बाहर निकल जाएंगे इन्हीं रजिस्टर्स के थ्रू. ये जो रजिस्टर्स हैं, वी आर यूजिंग इट फॉर द डिसिपेशन ऑफ हीट, नथिंग एल्स. अब ये क्या करता है, यहाँ से अब थोड़े समय बाद तीनों जो है इस लेवल पे आ जाएंगे. सो दिस इज व्हाट, व्हेन सेल्स आर कमिंग एट द सेम चार्जिंग पॉइंट, सेम SOC, सपोज दिस वन इज व्हाट 50% बैलेंस के बाद आफ्टर बैलेंसिंग, सो दिस वन इज व्हाट कॉल्ड द बैलेंसर. नाउ इट इज बैलेंस्ड बिकॉज एडिशनल चार्ज को हम लोगों ने हीट के फॉर्म में बाहर निकाल दिया. आई होप आई मेड इट क्लियर फॉर यू. ओके, एंड द नेक्स्ट वन इज व्हाट, दिस इज कॉल्ड द एक्टिव सेल बैलेंसिंग. अब ये थोड़ा डिफिकल्ट रहता है, थोड़ा सा कॉम्प्लिकेटेड भी है, और थोड़ा सा एक्सपेंसिव भी है. दैट इज द लोअर कॉस्ट बिकॉज रजिस्टर सस्ते होते हैं, आप लगाओ, हीट को बाहर निकाल दो, बैलेंसिंग हो जाती है. और जब ये इम्बैलेंसिंग होगी ड्यूरिंग द टाइम ऑफ चार्जिंग और डिस्चार्जिंग, तो वो अपने आप एक्टिव हो जाता है ना, बिकॉज वी आर यूजिंग द सेंसर, SOC सेंसर्स, जो हमें हमारे BMS को अपडेट देते रहते हैं फीडबैक थ्रू. एंड एक्टिव बैलेंसिंग, सॉरी, एंड एनर्जी ट्रांसफर in active cell balancing. What we are doing with the help of using inductors, ये बहुत important है. See, with the help of inductors and capacitors, yeah, we can say the transformers. What we are doing, we are transferring, suppose I am taking just two cells, just for example, so that you can got it. This one is two cell, it is charged up to the 90% here, and this one is charged up to the around 70%. okay, so पहले वाले में क्या करते थे हम, यहाँ से एनर्जी को, पहले वाले से हम एनर्जी को बाहर निकाल देते थे, लॉस हो जाता था हमारा एनर्जी का. नाउ व्हाट वी विल डू, we will connect it with the help of capacitors, inductors or transformers, and we will transfer this energy to this cell. okay, suppose this one is 90, this one is 70, so on an average that will transfer to this. The charge of this battery will go down and the charge of this battery will go up. And at this point, see, at this point, suppose at this point, this one 70% was there, and this one is what 90% was there, and up to the 80% that will be balanced. So this is the quite complex. See, this is what our battery packs are there, and here many sensors and BMS is there. This is what the complete BMS. Here you can see the complete BMS. okay, So this BMS has many components are there. So we are using 2, 3 inductors, capacitors and transformers, so that we can suppose this one was the higher charge and this one was the lower charge. So what will happen? This charge will transfer from with the help of this to this here. Okay, transfer to this. So that is what that process is called the active balancing. So active balancing can operate continuously during both charging and discharging thing. Got it or not? I hope I made it clear, everyone. And if you like, please like and subscribe the channel, share the videos with your friends, those who are interested in learning and upskilling himself, herself, whatever. And the benefits of cell balancing we already know about. The enhanced battery life, first thing, improved performance of the battery obviously, and increase the safety. Safety means what? Overcharging and over discharging safety. If the less charge battery keep in working, what will happen? That will over discharge. And if a high charge battery is keep into the charging, so that will be overcharge. So both condition is what? Avoided with the help of cell balancing. And how BMS manages this cell balancing, how it is doing? So BMS is first monitoring what is the voltage of each cells and what is the ampere or capacity. Also it is monitoring the what is the capacity of each cell and voltage of each cell. Control when imbalance are detected, the BMS activate the inappropriate battery method, whatever we have. If it is passive balancing, so BMS will activate. If we have active balancing, so BMS will activate that, please do your work, now it's your time. And feedback loop, it has, as already told you, continuously adjust the balancing process to ensure the cells remains within the desired voltage range. By maintaining balanced cell, the BMS helps to maximize the efficiency, safety and longevity of the battery pack. So this is what all about the cell balancing. Up to this point, I hope it is clear for you all. Now let's move ahead. Question number 4 is what? How BMS is monitoring SOC and SOH? This one, very much. This is what question asked in interviews. You can understand. With the help of question, understand the solution. So monitoring the state of charge, SOC, and state of health are the key functions of battery management system, that is called the BMS. Okay. So this is what the key function of it. Let's move ahead. And how it is managing? We have several methods of SOC estimation. And if you want, I will make a separate video with the help of example. Okay, just you need to comment below, and so that I can understand. I know that you are looking for that. I am a complete trainer of electric vehicle. So whatever you want, you can just mention in a comment box. Definitely you will get the video over that. And I want to just make happy those who are looking for the electric vehicle on YouTube, because they don't have time to visit the institutes. They don't have they don't want to spend the much money, even 50,000, 1 lakh, 1.5 lakhs in doing the electric vehicle course. So you can just learn here, attempt our examination, we will certify you as well. So first method is what? That is what? The estimation of SOC, that is called Coulomb counting method. And in this method we are using one formula. So this method is calculated SOC by integrating the current over time. See, I am writing here this one, SOC again, SOC with respect to time, what we are saying, SOC, okay, at 0. This is 0, okay, minus 1 upon Cn, and integration sign up where from where to where? From time 0 to t tak. And this is what the current of battery, BAT, I am writing here, over time, and this one is what? DT. So this is the formula, you should note it. This is very useful for finding the SOC. Okay. So if you want, you can comment. I will make a separate video by taking example how this integration part is working inside the estimation of SOC. Okay. And where I am mentioning here SOC 0 means initial SOC or percentage or fraction, and Cn here this one is what? Cn is what? Nominal capacity of battery, this is what? AH, and I bat means what? The battery current, positive for negative, positive for discharge and negative for the charge in amperes. and T is what the time, hours are in second. As per our comfortability we can consider it. And here in next one what we are going to the open circuit voltage method. So the second method is what to estimation of SOC was open circuit voltage method. And in this method BMS measures the voltage of the battery and cell, uses a predefined relationship between voltage and SOC to estimate the charge level. Okay, and जैसे what is what open circuit voltage method, this method require the battery to be at rest, no current flow. First off, majorly we are using this first method and this second method. There are 3, 4, 5 methods are there, but we are not using in industry everyone, but we can estimate, and these both are very accurate. No current flow for accurate measurement which can be challenging during the operation. See, SOC is what the function of our voltage, open current, right? Where VOC is what the open circuit voltage, and F is what function or lookup table is specific to the battery chemistry. So with the help of this one, second one, we can also get the SOC of the battery. And third method is what impedance based estimation, very less used in industry, even ना के बराबर है, but we should know कि what is it. कोई पूछ ले इंटरव्यू में आ जाए कि भाई कैसे करते हैं, so you can reply. So this advanced method measures the impedance resistance to accurate to current flow and of the battery cells. Changes in impedance can be correlated with SOC. See, and where SOC is what, if Z is what we are representing, Z is the impedance. Okay, Z is what the impedance. So SOC is a function of impedance. Impedance अगर change होगा तो we can SOC will also change. So Z is the battery impedance and F is the function of model L is specific to the battery chemistry. And if you want how it is exactly working, just let me know. We'll go for the separate video for estimation of SOC. Model based method, this is what Kalman filter. This one is very much important. Kalman filter method. That is called MBM, model based methods. तो SOC की ये जो K लिखा है ना, that is in suffix. It is very difficult to write in PPT and all. I am not much expert in that. SOC, they like it. This is I am mentioning it for you. SOC, this is K minus 1 and plus delta SOC, okay, plus K, and in suffix there is a K, and this is what V measured minus V predicted. So you can write something like this, V measured minus V predicted. So this is formula for estimation of SOC. So SOC K minus 1 is what previous SOC, मतलब before, पहले वाला क्या था, and delta SOC is the change in SOC based on the current model. पहले क्या था, अभी क्या है, there is a change, and this K is what, the K is a Kalman gain. Basically we are using it in MATLAB. Okay, so अगर आप MATLAB में भी ये सब कुछ करना चाहते हैं, let me know. And V measured is what the measured voltage and V predicted is the predictive voltage form of. जो डेटा की एनालिसिस BMS करता है ना, ये प्रेडिक्शन वहीं से आता है कि पहले हिस्ट्री का चेक करके प्रेडिक्शन दे देता है कि क्या वोल्टेज हो सकता है. नाउ लेट अस मूव अहेड एंड द लास्ट मॉडल इज व्हाट द एनर्जी बेस्ड मेथड फॉर एस्टिमेशन ऑफ SOC है. ध्यान रखना, कहीं भी पूछा जा सकता है कि व्हाट आर द वेरियस मेथड्स ऑफ SOC एस्टिमेशन. सो यू शुड नो अबाउट energy based method. This method is what calculates SOC based on a ratio of remaining energy to the total energy. बहुत important formula. हम लोग लिखते हैं कि SOC is equal to what, E total. What is what, E total and divided by E remaining. E total into A remaining multiplied by 100. So this one is what, the SOC equation. Total energy divided by remaining energy into 100 कर दो, SOC आ जाएगा. सपोज टोटल एनर्जी हमारे पास 300 है, रिमेनिंग एनर्जी हमारे पास 150 है, मल्टीप्लाइड बाई 100 कर देते हैं, है ना, तो कितना आ गया, SOC 200% बता रहा है. बाई रिमेनिंग कैसे रहेगा, कैसे नहीं रहेगा, वॉट एवर इट इज, आ गया एक सिंपल कैलकुलेशन करके. एंड सपोज हम मान लेते हैं एनर्जी टोटल जो था कुछ और है, कोई एग्जांपल ले लो 500 है, इधर अभी रिमेनिंग एनर्जी सपोज 400 है, इंटू 100 कर देंगे, है कि नहीं, तो 1 point something into 100 SOC, more than वो दिखा रहा है. And now you can see the remaining energy is what, 400, and total energy is what, 300 multiplied by 100, you will get some different answer, less than 1. 100 SOC is what, less than that. So similarly you can calculate. It is in terms of energy, nothing but it is in terms of energy only. And remaining energy in watt hour we will consider in, and E total in this one. Important note, हमने क्या लिखा हुआ है? The accuracy depend upon the initial SOC, temperature, aging and the measurement of errors. Okay, and combining method, coulombs, counting and OVC is often used in SOC estimation. Let us move ahead. SOC estimation अब कर लेते हैं. अभी हमें पता चल गया what are the various methods. So the state of health SOH of a battery indicates its remaining capacity or performance relative to its original state. When suppose at 100% a new cell is what, 100% SOC है. न्यू सेल का कितना है? न्यू सेल का है 100%. 100% है, यहाँ पर लिखते हैं 100% किसका? न्यू सेल का. After 1000 cycles I means charging and discharging, and suppose it is reached up to the what, 80%. So SOC is what now, 80%. It defines the state of health of the battery. जैसे अभी इंसान है, if it life of a human is what, 100 years, and if it is suppose I am 31 years old, that means what, my SOC is now remains 69% only. 31% of life is what, has gone already. So we are using the SOC with the SOH with the help of this capacity measurement. So BMS measures the battery actual capacity, how much charge it can hold. This is what SOH. New cells can hold up to the 100% charge. For that it has designed, but old cells cannot hold the 100% charge, है ना, compares to the original nominal capacity. See SOH formula क्या है? We are taking it actual capacity, SOH. You should note it, or you can just take a screenshot. SOH is equal to what? Actual capacity divided by nominal capacity और multiplied by 100 हम लोग कर देते हैं, हमें मिल जाएगा. ओके, तो ये SOCR, और we can write SOH is equal to what? C nominal divided by C current. राइट, नॉमिनल चार्ज क्या है और करंट चार्ज क्या है, मल्टीप्लाइड बाई 100. तो मेजर करंट कैपेसिटी नॉमिनल हम लोग ऐसे लिख सकते हैं, SOH इज इक्वल टू C नॉमिनल एंड डिवाइडेड बाई C current multiplied by 100. C nominal here define the current capacity as C current, and C nominal is what? This one is this one and this one is this one. And nominal capacity है ना, जब वो नया हो. Got it or not? So we can resistance based SOH, करंट में था तो resistance based होना ही था. So the BMS monitors the internal resistance of the battery cells, and increase in resistance over time significant aging reduce efficiency. This method compares the current internal resistance and R current was to the internal resistance when battery was new. So we have two kind of resistance. One is what? Resistance for new battery, and also the resistance for old battery. You can say means this is new one, this is old current one. करंट मीन्स ऑब्वियसली अगर एक बैटरी है 2 साल पहले बनाई गई थी, अभी हम लोग यूज कर रहे हैं इस टाइम 2 साल से, सो द करंट रेजिस्टेंस विल बी करंट ऑफ नाउ, एंड आर न्यू विल बी द व्हाट, ड्यूरिंग द टाइम ऑफ डिजाइन. सो SOH हाउ वी विल निकाल द न्यू वन, सपोज न्यू वन इज व्हाट 10 ohm, जस्ट आई एम टेकिंग एग्जांपल. R current now the resistance definitely has increased, suppose this one is 15 ohm multiplied by 100. Okay, so 10 by 15, so we will get around 50% of SOC, right? 2 by 3 around 60%, 0.6666 something, around 66% of SOC currently we have You got it or not? Suppose the resistance of new one was the 20 and after using if it is 15. Okay, let's make it more clear. Suppose the R new, the formula is there. Suppose the R new is what? Resistance when it was new, suppose it was 10 ohm for one cell. And now R current means resistance of now, suppose it is up to the 20 ohm, double हो गया. So we will find out the SOH is equal to 10 by 20 multiplied by 100. Now it is 0.5 multiplied by 100. So we have got the 50% of SOH. Got it or not? So similarly you can understand SOH कैसे हो गया. So resistance method is also good. Voltage based SOC. So SOH simply we have this formula. Voltage current, voltage nominal. I'm suppose the nominal voltage was 3.6 volt and current voltage was obviously maybe it has decreased. Suppose it is 1.8 volt multiplied by 100. So this is again 50% of SOC, right? 50% of SOC we got it. हमने क्या कहा कि करंट वोल्टेज सपोज दिस इज 1.8 एंड नॉमिनल वोल्टेज वाज ऑफ वन सेल 3.6 वोल्ट. सो वी हैव टेकन जस्ट नॉमिनल करंट डिवाइड बाय नॉमिनल मल्टीप्लाइड बाय 100. दिस इज व्हाट द फॉर्मूला ऑफ एसओएच. तो मैं आपको आई एम टेलिंग यू द नंबर ऑफ मेथड्स ऑफ कैलकुलेटिंग एसओएच. which is better for you, you can use, right? Go for the next slide. Energy based. So this is again for energy of current divided by energy nominal multiplied by 100. If I am saying the current energy which is decreased, suppose 200, just I am taking watt hour battery pack, and the nominal was suppose it was 400 of watt hour multiplied by 100. So what we will go 2 2 ja 0.5, so it is 50% of SOH. I think I made it clear for you. अभी कोई दिक्कत नहीं होगा. Let's move ahead. Cycle life SOC. Suppose the defined this is what depends upon the if the number of cycles completed is known, the SOH can be estimated. How it is? SOH was n remaining divided by n total multiplied by 100. n remaining means कितना cycle बचा हुआ. Suppose करो 10,000 cycle था हमारे पास. Initially it was 10,000 cycle and we have used around 5,000 cycle. Okay, 5,000 cycle it is charge or discharge, and 10,000 was the complete total. So we will multiply with 100. This one and 5 2 ja and 1 by 2 multiplied by 100. Again it is what 50% of SOH. I hope you understand. I made it clear for you. Now you can use any method friends to identify. ये आपको इकट्ठे कहीं नहीं मिलेगा. I am only who giving this premium content for you without any expectation. Yes, expectation is there. You should subscribe the channel. And question number 5 before the last one. So this you know how BMS is helping in communication. हमने बताया था कहीं आपको मिलता नहीं BMS communication भी कराता है, but I told you BMS is very much helpful for the communication. So battery management system facilitate the communication within a battery pack, ensuring all the components work together seamlessly and safely. And here not only internal, we have two kind of communication I am telling you. So first one internal, and also we will go for the external communication. External communication is also there. So first learn the internal. So BMS is doing the data collection related to the SOC, SOH, current, voltage, etc. And it is what we had, it has a communication protocols that is called the controller area network CAN. So a robust vehicle bus is standard designed to allow microcontrollers and devices to communicate with each other application without a host controller. So BMS can share the data with the controller. What is the condition of our vehicle, a battery pack especially. I2C and SPI common communication protocols. These are the name of protocols.
used within the battery. कई बार इंटरव्यू में पूछ लिया जाता है कि what is I2C and SPI, so you can say it is a common protocols used in within the battery management system for short distance communication between the integrated circuits. So you can easily qualify the interviews if you are looking for career in electric vehicle industry. And third one is what? Cell to BMS communication. So it is ensuring with the help of many sensors and other things, BMS along real time monitoring and management of cells, that we know already. And what are the external communication? So VMS can communicate with vehicle control units, VCU. I already told you कि जो हमारा controller है that is working with the BMS. BMS is what? A kind of controller which is controlling the complete battery pack. That can communicate with our vehicle communication system. That is what VCU, vehicle communication, a vehicle control unit, you can see. And the BMS communicate within the vehicle control unit to provide the vital information about the battery status, ensuring optical performance and safety of battery. Got it or not? And this is what? Energy management. The VCU uses this data to manage the energy consumption and distribution, enhancing the efficiency of the entire vehicle. So it is what? The VCU is getting the ready-made data from the, so just as per the requirement the VCU can use. User interface, the VMS can provide real-time data to the vehicle's dashboard or a user interface informing the driver or user about the battery status such as remaining charge, health वगैरह वगैरह. तो ये हमारा जो डैशबोर्ड होता है सारा डेटा वहाँ जाके डिस्प्ले होता है. So without communication it is not possible. Yes or no? Okay. So let us move ahead. I hope it is clear up to this point. Charging system, BMS communicate with the external charging system and to manage the charging process, ensuring that the battery is charged safely and efficiently. Previously we discussed that can change the rate of charge or discharge. So that means what? Without communication it is not possible. So that means right there is a system which can operate this rate of charging with the help of BMS. Got it or not? And charge management, it can adjust charging rates during the base. See friends, sometime the rate of my delivery lecture is very high and sometime it is smooth, less. So as per your comfortability, you can playback speed, you can manage the playback speed accordingly. Okay. Sorry for any kind of convenience. Sometimes I'm using a number of words together a very fast way. And the fourth one is what? The diagnostic tool. Obviously, if that will detect the problem, so it will try to best for the diagnostic, detail analysis and troubleshooting of battery systems. Let us move ahead. Data logging and analysis. So BMS is considering taking the saving the data, historical data over time, which can used for predicting maintenance, performance analysis, improving future battery design and all. If the BMS don't save the data, vehicle will not have a sufficient data. So the next version of vehicle without data information is not possible. Better. Remote monitoring. In some advanced system, the BMS can communicate data to remote system server or cloud-based performance for real-time monitoring and management. Even BMS can respond to the other servers if we have linked it. Question number 6. How BMS is empowering overall safety? If you understand up to the 5 point, you can skip the video from here. Your time is very much important, friends, because I am going to summarize all these into this section. And अगर आपको थोड़ा कम समझ में आया तो आप बने रहिए, यहाँ से आपका पूरा क्लियर हो जाएगा. So the battery management system ensures the safety of battery pack and its surrounding environment through several critical functions. And now let us go for what the function are there. So voltage monitoring and control, this is one. Overcharging protection, this is doing the overcharging, discharging protection, discharge protection. Monitoring and control of overcurrent protection, short circuit protection, this is done by the BMS. And also here the temperature monitoring and management, BMS is doing the complete. If temperature is getting high, so that means cooling system is activated. If it is going below the optimal range of the temperature, the heating system of the vehicle will activated है ना, cooling and heating subsystems, and cell balancing. If it is charging and discharging rate is different, our cell is taking less or higher charges, so that cell balancing is done by the battery packs. So equalize voltage, equalize current, capacity of the cells, so that is important. And isolation monitoring, leakage detection, and monitor the insulation failures, leakage that could cause the short circuits or electrical. If there is a leakage kind of thing, so that ensure that will detect, है ना. And communication and alert, just before we discussed about this. So what will be the next agenda for the next lecture? So there is a chances we can go for the third BMS, that is what, the advanced BMS, and I will do that only if I'll get the sufficient amount of requests, comments basically, that you are looking for the advanced BMS system. Okay, so I will go for the third one, third lecture of BMS, third lecture of BMS. Okay, and that is, I will say, the advanced. And still, if you are looking for the like a certification along with our company, and if you are looking for the study material and all, you can contact. I already displayed the number before, and so that we can ensure your time management and everything. Okay, thank you friends so much, thank you so much. You can share this video, please like, at least if you आप कमेंट नहीं कर सकते हो, you can like this video so that reach बढ़े. I want a maximum reach of this video so that maximum people can get the advantage of this. Even after paying lot of huge money, you will not get this kind of content. Okay, it's my guarantee. I'm giving you each and everything. So I want a maximum reach of this content. So please like, share, comment if you want to appreciate it. Okay friend, thank you so much. We'll meet in next session very soon. Bye.